Determine the force in each member of the truss and state if the members are in tension or compression. Set P1 equal to 45 kilonewtons and P2 equal to 30 kilonewtons. Okay, so today we have a very similar problem to the one yesterday. You can think of it like it's a problem A and B. We just have a little change in the forces acting on this truss system. So just to review what a truss system is, it's a collection of axial force members. And what an axial force member is, it's a rod that only resists loads in tension and compression. So this means there's no shear force, there's no bending moments acting on these rods right here. Okay, so and we'll take a look at that a little bit later. But of course, we're gonna start with the find variables, I should say. We have all the force in each member. So force member CB, force in member CD, force in member DB, and force in member DA. And we have to also determine if they're in tension or compression. Okay. So if we start with a free body diagram of point C. So typically for these truss systems, you'll be analyzing the pins in these truss systems, which join these rods together. You can see them at point A, B, C, D. Typically these do not resist moments, so they'll only resist forces in the X and Y direction. Okay, and there is some reactions acting on this beam, on this truss system, I should say, but for this problem, they're kind of unimportant because the problem isn't asking us to find these force members. So it'll be a free body diagram of point C. Okay, and we can start by drawing our loads on this. Yep, P1 of 45 kilonewtons. Remember CB acting on point right here for CB. And we have member CD right here for CD. And for determining which direction these forces are acting, you can typically take an educated guess, and if you get a negative sign with your answer, that means you were incorrect with how you direction these forces. You just have to flip the direction, basically. So we can start with a sum of the forces equation. Sum of the force in the X set equal to 0 because this truss system is at rest. So we have one force acting in this direction, force at CB, and it will unfortunately be equal to 0 because there's no other forces to balance out a potential force right here. So that'll be our first find variable, force in CB, and 0 force cannot be in tension or compression. Okay, so we can move on to our second equation. Force in the Y set equal to 0. That 45 kilonewton load acting downward, so negative sign. And we have force CD acting upward, set equal to 0. Should find that force in CD is equal to 45 kilonewtons. And that will be our first find variable. And to gauge whether this is in tension or compression, we can take a look at the truss structure we have here. So we know CB, there's no force acting through member CB, but there's force acting through member CD here. And so we know the force is acting upward. So we'll be resisting a force like this. Okay, and these arrows are in the perspective of the joints. So that's the force acting on the joint. And there'd be an opposite force acting on the rod. Okay, so we know to balance out the forces acting on member CD, there must be an upward force pushing on the member or a down force pushing on the point D. And so we can look at this and we can say if these two forces right here are pushing on the 2 points, we know this beam must be in compression. So if we have a force pushing these 2 points, the beam is being smushed, basically. Member CD is being smushed, basically, so we know that it is in compression. Okay, so let's write that right there. C in parentheses works for that. And we will continue on to point D. Let's be analyzing a different point right here. We need two free body diagrams, two distinct free body diagrams with the same sum of the forces. So you have member CD acting on this point, and it'd be acting the opposite direction that it is on point C. So it'll be that same 45 kilonewton load acting downward this time. And then we have force P right here of 30 kilonewtons acting towards the right. Now we have member DB right here. It's me acting on an angle right here, like that. And to find the angle it's acting at, we can look at our problem up here. And if you multiply all these sides by 2 right here, 4 meters here, 3 meters here, you can see this is a 3, 4, 5 triangle. It's a similar triangle. So we can use the same ratios to define the components of x and y here. 5, it'll be 4 in the horizontal and 3 in the vertical. Okay? And we also have force FD right here. No, FDA, sorry. And this will be force DB. Okay? So we can sum the forces right here. Let's actually start with summing the forces in the y direction, because we only have one unknown for this equation. So now 45 kilonewtons is acting downward, and then we have the positive component, the vertical component, sorry, of force dB, which is going to be 3 over 5 force dB, and we're going to set that equal to 0. And if you plug that into your calculator, you should find force dB is equal to 75 kilonewtons. To find whether it's in tension or compression, we can take a look at our diagram right here. Since we got a positive answer, we know that we drew the direction of the force in the correct direction. So we know it'll be acting like this. The force at D and B will be acting like that. The rod is pushing against the points like that. So we know this must be in tension. Because if you imagine kind of the beam right here, it's being pulled apart right here. So the forces at these 2 points will have to kind of push it in to keep it at rest, if that makes sense. Okay, so we know that this will be in tension, in fact. Up here next, find variable. Force dB, and that is in tension. Okay, and now our last equation, sum of the force in the x of point D right here. We know that there is a 30 kilonewton load acting towards the right here, and then we have the horizontal component. 4 over 5 force dB, which we know is 75 kilonewtons. We have force dA acting completely in the horizontal direction right there. And if you plug that into your calculator, you should find force dA is equal to 90 kilonewtons, and we got a positive answer for this. So we know that we're correct with how we assume the force to be initially. And again, if you take a look at it, this beam is going to be in compression. This rod will be in compression because the force exerted on the 2 points is being opposite. So we know that this rod must be in compression. Okay. Compression, and that'll be our last find variable. 90 kilonewtons, and that will be in compression. Okay, so you have to really be careful whether these rods are in tension or compression right here. There's no shear forces, no bending moment acting for these. And really the main benefit of a truss system is since the loading is only tension or compression, we can take materials that are generally weaker in the shear direction and only load them in tension or compression. For example, wood is very strong in tension or compression. For example, if you take a matchstick and try to pull it, it's going to be very difficult versus snapping it in half. That'd be very easy. So that kind of shows the tensile or compressive strength of wood, which you'll see a lot of times in roofs of houses. So it's a cheap way to resist a lot of force. But anyway, we found all of our fine variables right here. So that's it. We're done.